Okay, good morning to all.
Sir.
Good morning, sir.
Good
Good
morning.
morning, sir.
Good morning, sir.
Good morning. Let's start. Uh, Let me share my screen first. Okay, so is my screen is visible to you? Check once.
Yes, sir.
Okay. So today we will see some topic based on module 4. Okay. We already saw the part of BJT and also we know about the JFET junction field effect transistor and also we know about the MOSFET. Right? Now we also saw the circuit like this. We was having some collector junction. We have some emitter part. We know this is by base of it. Okay. But how the circuit can be designed with the help of BJT, different type of circuits. Okay. So numericals definitely based on the circuits, right? They will give certain circuit based on BJT, and you have to find out the value of output current and output voltage. Output current and output voltage. These are the two basic questions which is possible. That means with the help of any BJT circuit, they will give certain circuit and you have to find out the output current and output voltage. Basically, we are having the three types of bicycle. That means circuits, you can say. That means external voltage, how we are applying the external circuits, external voltage to a BJT. Okay. So first one is the fixed bias configuration. Fixed bias configuration is also called as the base bias. Now, if I draw the circuit, one BJT I am taking, okay, and in the direction of current is in the emitter part. So it will be a emitter, okay, and this is collector. Always in the collector, you will see one resistor, okay, and in the fixed bias configuration, you, you will you will get one resistance across the base, that is RB, okay. And in the case of fixed bias, there is no resistance in the emitter part, like this will be there, okay. You know the current IC will flow here, IC, and I am providing here suppose VCC, okay. This is the input voltage that we are providing in the circuit. This is RB, and you know in the RB we can assume the IB current is flowing, and this is IE current is flowing like this. Okay, the voltage across this is the collector region, this is the emitter region. So the voltage across this will be VCE. The voltage across collector to emitter is called as the VCE. So how and our question, as I told you, they can ask you to find out the output current. In this output current will be IC. In all the circuit, it will be IC, will be the output current, and output voltage. Output voltage is VCE. Okay, how we can find out? You have to apply the KVL. Okay, so in this you apply the KVL from here to here. Okay, from starting from VCC up to the ground. Okay, so now I'm applying here. I'm just changing the color so it will be visible to you. How I will apply? See, VCC, VCC minus IB current is flowing here. So IB, RB. Okay, the voltage across this one is VBE. This is the base and this is the emitter. So this is VBE, right? So minus VBE equals to 0. This is the last one is ground. Okay, so from here you can see, you can write down that VCC minus IB RB minus VBE equals to 0. We have to find out IC. As you know, IC is equals to beta IB. So if I find out the value of IB, I can find out the value of IC, right? So from here, you can find out the value of IB just by simplify this equation. So that will be VCC minus VPE divided by RB, right? This is IB, so you can find out the value of IC is equals to beta IB, that is VCC minus VPE divided by RB. I'm just telling you the procedure how we can proceed for such circuits. Okay, in the fixed bias, you will not get any resistance across the emitter. Okay, now you have to find out the value of VC in the output part, right? That means you have to apply the loop KVL in this outer loop. So I'm writing the equation first. Here, if you apply it, you will get VCC. This is the VCC, right? Minus ICRC. This is the current and the resistance, minus VCE. And here no resistance, it will be 0. So equal to 0. So I am rewriting this equation here. VCC minus ICRC minus VCE is equals to 0. And if you find out the value of VCE, it will be equals to VCC minus ICRC. Okay. So like that, you can apply the KVL for any circuit. This is the fixed bias configuration. Now we will see for the self biasing.
Sir,
Yes.
installer circuit.
So now you see self bias configuration. Self bias configuration is similar to fixed bias configuration. Only one change you will get. What is that? In case of fixed bias, we was not having any resistance. Okay, here in the emitter region, but here you will get the resistance will be there in the across the collector region, and RB is also there in the IB region like this, and you will get the value of VCC, right? The voltage from base to emitter is VBE, and here it will be VCE. Okay, and this is the current flow like this. If you don't know the value of VBE, this is the threshold voltage of any PN junction. So you can assume 0.7 for this silicon and germanium, as we have seen, right? The same thing, if you don't know the value of VB, you can assume 0.7. Now, if you want to find out the value of IC and IB, how you can find out? By applying the loop here in this side. So what you will get? VCC minus IBRB minus VBE minus IERE. Only one change you will get, that is the current flow in this one. I'm assuming as RE, IE, and that will be equals to like this. Okay, this is the first equation. Now the similar you can write down for the outermost part, that is what? VCC minus ICRC, that is the VCC minus ICRC minus VCE, that is the voltage across the collector to emitter, minus IER. Okay. Now after that, you can solve by substituting its value. For example, you have to find out from the first equation, you have to find out the value of IC. So how I will write down? I can write down IC is equals to beta IB, right? And IE is equals to, because we are having the IE also, so IE is equals to IB plus IC. So by using these two equations, if you substitute it here, you will find out the value of IC. Because we have only two currents, you know the value of IB is related with IC, and that IE is equals to IB plus IC. So if you substitute it here, you will find out the value of IC. I'm just telling you to the procedure how you can proceed for the circuit like this. Okay, this is the self bias configuration. Now we are having the third type of biasing also, that is called as the voltage divider bias. Voltage divider bias. Voltage divider bias is like this one. We are having two resistance like this. Here our RB is replaced by two parallel resistance. This is VCC, this is RE, okay, and this is RC, This is R1, this is R2, and this is the current flow. You know, this is collector, this is emitter, this is base. If you see such circuit where this is VCE, right? It means they have a parallel resistances R1 and R2, okay? And the voltage across this, across R2 will be your voltage. So how we will find out for such circuit? You can apply the Thevenin's theorem. You know the Thevenin's theorem, there where we can find out the value of VTH and RTH. Okay. So here it will be fixed actually because we are having only two resistance. So RTH will be the parallel combination of R1 and R2. So you can write down R1, R2 divided by R1 plus R2. And by applying the voltage division rule, you can find out the value of VTH is equals to VCC because VCC is our input. For example, if two resistors are connected like this, so can you find out the voltage across any resistor? Yes, we can find out by applying this R2 divided by R1 plus R2. Okay,
Sir,
so yes,
sir, R2's the voltage across R2 will be the input voltage,
yes,
right?
input voltage, yes,
Okay, okay. And supplied voltage is VCC.
yes.
Okay.
Okay, so like that. After that, it will, if you redesign this circuit, it will be like this one. Here we are having the VTH. Okay, here we are having the RTH, and this is your base terminal, and then this is will be RC, this is VCC, and this is your RE, like this, right? After that, you know the procedure, how you can apply the loop here. Okay, so same thing you can do as you have done earlier. VTH minus I will be IB because base current will be there. So it's IB into RTH minus VBE, that is the base to emitter voltage. So VBE minus IERE. So that will be the first equation that you can write down from this side. And from this side is same as that earlier, that is VCC minus ICRC minus VCE minus IERE, right? That is similar actually, VCC minus ICRC, then VCE here, right? And then IERE, sorry, IERE, understand? So like that, there is three possible combination of questions possible actually. Now we will see one numerical based on this one. So first question that we will see is based on one circuit. Okay. So here one question is given. Yes.
Could you go up for a minute?
Yes.
Can you wait for a moment? So next we are having one question. For example, I'm giving you one question. Here they have given one BJT like this. Okay. The current flow is like this one, and they are saying one resistance is connected here, that is RE. And here we have a VEE. IE is coming out like this. And this is VIB current. And this is RC. And this is VCC. For example, the value of RE they are giving as 1.5 kilo ohm. VEE they are giving suppose 8 volts. IB they are actually grounded directly. And RC they are giving 1.2 kilo ohms and VCC is 18 volts. What you have to do here, whenever you see such circuit, you have to apply the KVL directly. Okay, but these voltages are important. The voltage across E to V you have to assume as VBE. Okay, this voltage you have to assume as VBE. They will not specify, you have to assume here, right? Same thing between B to C, you have to assume as this is VCB. Oh, sorry, VCB. After that, you can apply the KVL. Okay, so if you apply the KVL here in this loop, I'm just changing the color so it will be visible to you. If you apply KVL here,
you will get VEE minus IERE minus VBE. Now question is what you have to take in terms of VBE. If VB is not specified in the numerical, you have to assume as 0.7 volts always. It's fixed actually. Okay. So if you apply it here, you can find out the value of IE, right? VEE minus VBE divided by RE will be your IE. So substitute it. VEE is what? VE is 8 volts. VB is not specified. That means you have to take as 0.7 volts. That is 0.7 volts. RE is given to us is 1.5 kilo ohms. So you can put 1.5 kilo ohms. Now you tell me the answer after calculating.
Sir, what actually do we have to find in this question? Like what's the
Always see, always you have to find out the value of IC and VCE. If it in the numerical they say that design a circuit. Otherwise, they will specify find out IE, find out IV, find out IC. Then by with the help of equation only you see it, right? For example, in this question they said find out the value of IC. Okay, so what I will do first, I will find out IE, and then with some equations we can go for the IC like that.
Okay, okay.
Okay, so what value you are getting here?
4.86
milliamperes.
4.86
86.
milliamps. Okay. So this is how we can find out the value of IE. Now, for example, they asked the value of IC. Okay, and you can see the value of IB is 0. That means IE is equals to IC plus IB, and IB is 0. So both are same thing. Means you can assume that IC is equals to IE. IC is equals to IE. So you can say whatever we have calculated is the same answer, right? Now you apply the KVL in the second loop. Okay, in the second loop. So you know, we already seen it, VCC minus ICRC minus VCB. Don't forget to use this voltages. Okay, this is the voltage across collector to base. They will not specify these voltage in the numerical. They will directly give this value, this circuit. Okay, so equal to 0. Now from here, can you find out the value of VCB? For example, you have to find out VCB. So VCB will be equals to VCC minus ICRC. And VCC is what we have taken as 18 volt, for example. So 18 volt, we know the value of IC, we calculated, right? IC is equals to 4.86. So 4.86 milliamps into RC was 1.2 K. Okay, so this is numerical, and you can tell me the value of VCB now. Tell me the value.
Sir, I have a doubt. How did you write IB is equal to 0, sir?
Because here there is no resistance. Actually, this is directly connected to ground, and always remember the IB value is very small. Okay. So in that reason, if you are not having any current, they have not specified any current, and they are not giving the value of alpha and beta, you can assume the IB is equal to 0. Always remember IB will be in micro amperes.
Yes,
So
sir.
12.17
Sir, even
volts.
if it's not,
It will be 12.117.
17, sir.
It's volts, right? Volt. Okay, now I am trying to use this BJT as an amplifier, Okay, so for example, you have one BJT like this. Here I am giving the value of IB, right? You know, here you have IC, here you have a IE. If this is the emitter region, this is the collector region, and this is the base region. If you are connected in the active mode. What is the active mode means? The input terminal is reverse bias or forward bias. You tell me. Input and output characteristic we saw, right? Forward bias and reverse bias. In that case, it will be in the active mode and you can use an amplifier, right? Why we are calling is as an amplifier? Because we are giving the input IB and we are getting the output IC. And you know the relation. What is that relation? That beta is equals to IC by IB. And the value of beta is around 100, sometimes 100. Okay. If you are using for the common emitter, okay. So in that case, it will be IC by IB. And the ratio, see, you are giving the input in some whatever, it will be in microamperes, and you can get the value in milliamperes. Okay. That's why this BJT, when you are connecting in the active mode, you can get the amplification. Okay. The detailed analysis we will do after CAT exam, but how the question they can ask is what, how we are doing this amplification part, right? So one question you see how they can ask you. They are saying the input resistance. Input resistance. They are giving suppose 20 ohm. Okay. And they say that output resistance. That means input resistance you can assume as what? See, if you are having one NPN transistor like this is your emitter, this is your base, and this is collector. They are saying the input resistance, that is Rn, they say that 20 ohm. Okay. And the output voltage, the output resistance, that is R out, they said that 100 kilo ohms. Okay. And they say that, for example, I am providing one signal here that is of 500 millivolts. Okay. So how we will find out how much amplification they have done? Okay. So first, you know the value of signal that is in the volt. So you can find out as this is IE. Okay. And you know the input resistance, you know the voltage. So can you find out the value of IE? IE will be equals to the voltage divided by Rn. So voltage is 500 millivolts and Rn will be 20. So after solving, you will get 25 milliamps. That means we are giving the IE as an input and we are getting, which is equals to 25 milliamps. Okay. Now, for example, they have given the RC value as 1 kilo ohm. Okay, they have given 100 kilo ohm, for example. Okay, so can you find out the value of voltage here? It will be IC. So, but if you multiplied IC by R out, you will get the output voltage V out. V out will be equals to IC into R out. We know only IE. For example, I'm saying this IE is equals to IC because we can assume, because we know that IB will be very small. So we can assume IC is equals to IE, right? So IC is, if it is equals to 25 milliamps and the resistance is 100 kilo ohms, if you multiply it, what you will get? It will be around volts go 2500 like this, right? So how you will find out the amplification, voltage amplification? Voltage amplification will be the ratio of output by input, right? So you are getting output as 2500 and you have given the input voltage as 500 millivolts. So if you divide it, you will get the amplification part. Okay. So here what you have to see, here you have to check the current and then check the output voltage. The ratio of output voltage divided by input voltage will give you the voltage amplification. This is not much important, but the question which is based on this one will be from the RC phase shift oscillator. So let's see RC phase shift oscillator. So in the RC phase shift oscillator, they are
Sir,
using, yes.
How did we take IC is equal to IE?
See, if it's not specified in the numerical, they are not giving the value of alpha or beta. Then in that case, you can assume IC is almost equal to IE because this is the IB is the recombination current and which is very small. So you can neglect that. In that case, because you know, IE is equals to IC plus. If I am saying that recombination current is very small, IB is, you can neglect it. In that case, you can assume IC is equals to IC. But this is possible only when the alpha or beta value are not given, or even leakage current is not given to you. ICEPO, ICVO, CEO is not given to you. In that case, only you can assume. If in the numerical, they are not giving any value of it, then you can assume the value of IC is equal to. Okay.
Okay, sir.
Now, for the RC phase shift oscillator, how the design is like, you require one voltage divider biasing circuit. Voltage divider. You've already seen this thing, right? What amplifier I'm taking? Suppose this is R1, this is RC, this is RE, one resistance R2 here. Okay. First, I'm telling you what is the meaning of this oscillator. Oscillator is a circuit which generates the sinusoidal output. Sinusoidal output without giving any signal. Without giving any signal. But for the amplifier, we require DC input. DC input, for example, suppose I am taking 10 volt. Okay. This RC circuit is what? One amplifier is there, amplifier. And we are also having one feedback circuit. Feedback circuit. This feedback circuit you can generate. This feedback circuit you can design with the help of either RC circuit or with the help of LC circuit. Okay. This amplifier provides 180-degree phase shift output. Okay. If you provide three parallel RC connections like this, if you provide one connection like this, sorry. 1 minute, I'm just designing the circuit once again. Here you are having one amplifier. And the resistances, the capacitor are connected like this. 1, 2, and 3. Like this. Okay. And the resistance are connected like this. The value of the resistance should be same, right? The R5, suppose this is R4, this is R3, this is R2. These all the combination of capacitors. Suppose this is 1 nano, this is 1 nano, this is 1 nano, and they are connected here with one capacitor to the output voltage. It is a long circuit, but don't bother about this long circuits. Okay, here we are providing the VDD, that is the input voltage. And this is one amplifier circuit. So I'm just changing the color to show the effect of it. All are connected, right? These all are connected. This is amplifier circuit. In between, you have an amplifier circuit like this. This is your amplifier circuit. Here you can see the combination of a capacitor and resistor. These capacitor and resistor. One combination of capacitor and resistor can provide a 60-degree phase shift. Okay, one combination of RC circuit. So here we are using one combination, 2 combination, and 3 combination. So 60 degree, 60 degree, 60 degree. So total 180-degree phase shift you will get from the RC circuit. and 180-degree that is provided with help of amplifier circuit. Okay, so total 360, that means you will get the same signal without providing any input here in a signal. You can generate a sinusoidal output. Now, if you're generating a sinusoidal output, it will have certain frequency. Okay, actually in the numerical, they will ask you to find out the frequency of the output sinusoidal signal. That value will be equals to 1 by 2 pi RC under root of 6. Why it's 6? It's equals to 2 pi RC divided by 2n. That means how many RC combination you have taken. As we are taking only 3 combination, so it is equals to 2 into 3, that will be equals to 6. And always remember these values, these capacitor value will be same. Okay, if you are assuming this is C1, this is C2, this is C3, the value will be same. Okay, so this C will be equals to C1 equals to C2 equals to C3 equals to C. Similarly, this R will be equals to R1 equal to R2 equal to R3. You have to see only the feedback circuit, that is R4, R3, R2, whatever is there. It will be same. These all R4, R3, R2, R4, R3, R2, all will be same that of R. Then you have to substitute. For example, I am taking one example, right? I'm just again changing the color. Don't bother about this amplifier circuit. Don't see this amplifier circuit. Okay, what you have to do, you just check these capacitor and resistor value. For example, they say this is 1 nanofarad, this is 1 nanofarad, and this is also 1 nanofarad. They said that the R value is 1 kilo ohm. This is 1 kilo ohm. This is 1 kilo ohm. Definitely, they have to give the same resistance values, right? And same capacitor values. So this will be your C, this will be your R. Okay. So now you can, if you can substitute it here, it will be 1 by 2 pi. R, that is 1K, for example. So it will be 3. C is suppose 1 10 raised to the power minus 9 under root of 6. That is the frequency that it can generate. Okay, let's complete this one and tell me the answer. Tell me the answer of this question. F is equals to what?
0.06 times 10 raised to minus 6.
So how much? Once again,
0.065.
0.065. How it is possible? This is 10 raised to power minus 9. This is 10 raised to power 3. So you will get 10 raised
Oh,
to
sorry,
power
10 raised to minus 10 raised to power 6. It will go up.
10 raised to power 6, like this, right?
So,
Okay. So now next question they can ask, like, RC phase shift oscillator uses capacitor 5 picofarad. Find out the value of resistance to produce frequency of 800 kilohertz, for example. So you have to use the same formula, right? That is F is equals to 1 by 2 pi RC under root of 6. Okay. Capacitor, they gave the fundamental that oscillator frequency. You have to find out the value of R. So it will be 800 into 10 raised to power 3 equals to 1 by 2 pi R. You can have to find out. C is 5 into 10 raised to power minus 12 and under root of 6. So you can find out the value of R from here. Understand? So like that, they will ask question. If the question is based on this was the question based on RC oscillator. If the question is based on the LC oscillator, then the circuit will be same. Only the formula of frequency will be changed, and it will be equals to 2 pi under root of L1 means L and C, LC. Okay, this will be the formula for LC oscillator. Now we will go for the MOSFET part. as we have seen, the configuration in BJT, it can also connect in the common collector like that, right? So they can, in the MOSFET, they can also connect in common source, common gate, and common drain configuration. What is the meaning of common source? If you are having a MOSFET like this, for example, okay? This is the drain terminal, this is the source terminal, and this is, for example, the voltage divider circuit only. Suppose this is R1, this is R2, okay? And like this, we are taking the output from here. This is the output. Common source means what? Source is common for your input and for your output also. So that means you are giving the input from the gate terminal and you are taking the output from the drain terminal. Similarly, if I ask you to tell me about the common gate. Common gate means what? Gate is common. That means gain is common for input and output. So what I will do, I will provide the input from the source and I will take the output from the drain. Now, same thing is for the common drain configuration. That means drain is common for input and output. So the different things I am making one table to you, so that will be easy. Okay. I'm saying about the common source. This is for the common gate and this is for the common drain configuration. Okay. Now, if I say, what will be the input terminal? Input terminal. In case of common source, it will be gate. In case of common gate, it will be source. In case of common drain, it will be gate. Okay. Now, in case of voltage gain, if I ask you, no, sorry, output terminal, you need to tell them. So it will be drain. It will be again drain. And this is source terminal. Voltage gain is very important part. Voltage gain. The voltage gain will be AV is equals to minus GM RD. That is the drain resistance. Similarly, AV will be equals to GM RD. And in this case, the AV will be, this is the voltage gain, RS divided by 1 by GM plus RS. And you know how we can find out the value of GM? GM is equals to GMO, that is the maximum transconductance, 1 minus VGS by VP. If they will provide you GMO, you can find out the value of GM, just multiply with RD, you will work out. Okay. No?
Sir, 1 second, can you just show the circuit and the table? Just a second.
Yes.
So can you explain the circuit again, sir?
See, this is the voltage divider circuit, MOSFET circuit. Here we are using the two resistors as we have done in the BJT. This is the RD resistance. This is the drain resistance. Similarly, just I changed the BJT with FET. Okay. This is source terminal, this is drain terminal, and this is the gate terminal. Okay. If the source is common, this is source, right? We are providing the input from here and we are taking the output from the drain. That means source is common between the gate and source for the input, and the source is common, actually common for input and output from where we are giving. Okay. So if it is, now you see the input impedance. How you can find out the input impedance?
What is GM, sir?
Transconductance, input impedance. Input impedance in this case, it will be Zn is equals to R1 parallel with R2. Zin in this case will be Rs parallel with 1 GM. GM is transconductance, reciprocal of your resistance. And this is R1 parallel with R2. And similarly, the output impedance in this circuit will be equals to Z out equal to RD. Okay, Z out will be equals to RD. And this Z out will be equals to RS parallel with 1 by GM. I will explain you through numerical, so that will be easy and that will be important actually. Okay. How they will ask question based on this. Okay, so let's see a numerical. Okay, what is this? They have given one FET like this. They said that RD is equals to 3.3 kilo ohm. They are giving VDD equals to 12 volts outside. Okay, one capacitor is connected like this, and they said this value of RG is equals to 10 mega ohm. Here they are providing one signal that is 100 millivolts sinusoidal RMS root mean square. Okay, and this is one RS resistance which is equals to 2.7 kilo ohms, and one capacitor is connected as 10 microfarad. This is C2. Okay, and from here you are taking the output V out. Question is, what is the RMS output voltage? Find RMS output voltage. That is our question. So you see, first always you have to find out the value of VGS. Why? Because ultimately we need to find out GM, and GM is equals to GMO, that is the maximum transconductance, 1 minus VGS divided by VP, right? And in this question also they have given the value of VP is equals to minus 10 volts. They are also given the IDSS, suppose 8 milliamps, and ID they have given as 1.9 milliamps. These things also provided in the numerical. We have to find out the RMS output voltage. Okay, so what is the formula that we can apply is GM. We need GM because we need to find out the amplification also. If you need to find out amplification, voltage again amplification, the AV will be equals to GMRD. Ultimately, GM is very important. That is transconductance. Okay, so for this we require VGS. That is the first step we need to apply. VGS, that is the gate to source voltage. If you come here and see, if you want to find out the gate to source, this is gate terminal and this is source terminal, right? So that will be actually this resistance, which is with the voltage which is across this one will be your VGS. Okay, so VGS will always be equal to minus ID into RS. Drain current, because this is the drain current flowing from here. Okay, this is the drain current flowing from here. So this ID into RS will be your VGS. ID is provided in our numerical, that is minus 1.9 into 10 raised to the power minus 3. And RS is also provided to us is 2.7 into 10 raised to the power 3. So from here, you can calculate the value of VGS, which is equals to minus 5.13 volts. Okay. Now, as you can see, we require this GM. Okay. On that, GMO is very important. That is the maximum transconductance. The formula of GMO is equals to 2 into IDSS divided by VP. Okay. If in the numerical, they are providing in place of VP is equals to VGS offset, both are the same thing. Okay, you can assume VGS and VP, VGS offset equal to VP. Okay, so it will be what? 2 into IDSS is also given to us, that is 8 milliamperes. So it will be 8 into 10 raised to the power minus 3. And this VP is given to us as 10 volts, right? So 10. So if you solve this one, you will get GMO is equals to 1.6 into 10 raised to the power minus 3. Now we have this GMO term, that is the maximum transconductance. We know the IGS, we know the VP, so we will go for the GM calculation. So the this is GMO. Okay, so GM is equals to GMO, that is the maximum transconductance, 1 minus VGS divided by VP. So from here, if you apply it, GMO we calculated as 1.6 into 10 raised to the power minus 3. This is 1. VGS we calculated as minus 0.13. VP that is given to us is minus 10 volts. So you can tell me, you can calculate from here, that is GM is equals to 779 into 10 raised to the power minus 6 seconds. Okay, So always remember, for such circuit, you have to calculate the value of GM first, transconductance. Now, if you know the transconductance, you can find out the current gain, that is GM into RD. Okay, GM into RD, that you can see it here. AV is equals to GM into RD, right? As this was the common source, so it will be minus GMRD, right? So minus GMRD. So GM is what? 779 into 10 to the power minus 6. RD is, that is the drain resistance. This is 3.3 kilo ohms. We can write down 3.3 kilo ohms. If you find out this one, it will be 2.57. That means you know the value of AV, but what we require, that is V out. V out always equals to AV divided by AV into V in. Why? Because AV is equals to output voltage divided by input voltage. Okay, this is actually the formula. If you solve, you will get V out is equals to AV into V in. We know the current amplification gain, that is 2.57, and V in that we provided. What is that? 100 millivolts. So if you multiply with 100 millivolts, you will get the value is equals to 2.5. So 257 millivolts, like that. Okay, so these are the types of question which is possible from here. Okay, so they will provide you the value of VP. Okay, you can go with this formula. This formula is GMO formula, and you can find out the value of GM, that is the transconductance. And from this table is very important. If you know these things, means if you know the GM, you can find out the voltage gain. Okay, and voltage gain is equal to the V out by V in. So if you know the value of V in, you can find out the value of V out. One more question, which is near to it actually. Okay, I'm solving one more question related to it. You have one voltage divider circuit like this, and this is FET. And here they said we are applying 12 volt input. This is RD, they have given as 3.3 kilo ohms. This is suppose 6.8 mega ohm. This is 1 mega ohm. And this is 1.8. Okay. This is R2, this is R1. And they said that the VD, that is the drain voltage, VD is equals to 7 volt, for example. They said that find out the value of ID and VGS. Find out ID and VGS. It's similar as we have seen the voltage divider in the BJT. Okay, so here what you have to do, first you find out the value of drain current, because this is the 12 volt. Okay, this is the drain voltage, in between drain voltage unit. So if you apply it up to here only, you will get the ID value. Okay, this is VD. Exactly at this point, what is the voltage? So this is the starting point, this is the end point. You have to apply the loop here. So that is equals to what? Suppose this is VDD. Okay, so if you apply the loop here, it will be VDD minus ID into RD, ID into RD minus VD. This is the point voltage. Okay, so if point voltage is given to us, that means the voltage at this point only, if you know, so you can apply up to here only. So what you will get? ID is equals to VDD minus VD divided by RD. So in this numerical, the value was 12 volt for the VDD minus 7 divided by 3.32. So you can get the value of ID, that is 1.52 milliohms. Now, for example, you have to find out the value of IS. This is the IS, right? This is source. This is source, this is drain, this is gate. Okay. So ID, that first part is over. Now we need to find out the VGS. How we will find out the value of VGS? VGS, if you have to find out, it will be VG, that is the gate voltage minus source voltage. So first you need to find out the gate voltage. How you will find out the gate voltage? By the voltage divider rule. Okay. VG. For VG, voltage divider rule, that is VTS Thevenin theorem. Okay. So it will be equals to VDD into R2 divided by R1 plus R2. Okay. This is the VTH as you have calculated in BJT part. So this is equal to this part. So VDD is 12 volt. If R1 plus R2 is 7.8 mega ohms and 1 mega ohm. So you will get around 1.5 volts. Okay. Similarly, you can find out the value of VS. VS is the voltage across this source, and we are assuming there is no voltage drop here. So this ID is equals to this one. ID is equals to IS, for example. Okay. So in that case, what will be the value of VS? VS is equals to ID into RS. So that will be equals to 1.52 into 1.8 kilo ohms. That will be cancelled and you will get 2.74. This will be the value of VS. If you know the value of VGS and VG, you can tell me the value of VGS is equals to VG minus VS. That is equals to minus 1.20. Like that, they will ask you the question. So most of the part, which types of question we saw, okay, you just solve these questions, and also you can refer the worsted book for these circuits. And for the numerical, whatever types of numerical I solved in the class, similar question you will get. Okay. Yes. For
What
the
did you just
yes,
refer, sir? What book did you just refer?
Worsted.
Could you spell it, sir?
It's one. Okay, I will do one thing. I will share you the link for that PDF directly. Some books I will give you the link in the this team only. Okay, so after
Yes.
1 hour you check in the this meet chatting. So here I will share you the link for these books.
Okay, so could you please upload today's notes also, sir?
Yes, of course. That I'm just 1 minute. I'm uploading now only, so you can save it. Okay, so please download this one and prepare similar questions. Actually, we have completed most types of questions. Okay, so for every question you try, solve at least 2 or 3 questions, so it will be easy for you. Okay, that's all from my side. If you have any doubt, you can ask. I will upload the link for that PDFs, means the books actually, so you can solve the numerical formula.
Sir,
Yes.
what's the weightage of modules, the modules for the exam? 3, 4, and 5?
3, 4, and 5 equal weightage. 10 marks question. 10, 10, 10.
Okay. And 5 mark, one question will be 5 marks, right? We'll have two
Yes,
5 mark questions.
5, 5,
Okay.
5, 5. Total 6 parts will be.
Okay, sir. Thank you.
Yes, sir. Up till where do we have in 5, sir? Module 5?
What?
Up till where do we have for CAT 2 in module 5, sir?
Okay. Up. So module 5, 3, 4, 5.
Full module, sir. 3, 4, 5.
Yes, good. We completed all the parts.
Okay, sir.
Okay, thank you. You can download the today's notes, and I will upload the link. Actually, I will share the link here directly in the meeting chat. Please download from there after 1 hour. Thank you. Thank you so much.
Thank you, sir.
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 Thank you, sir.